Consider the probability density function f of x equals a half of x for the domain of x between 0 and 2 inclusive. Part A, check that f of x is able to be a probability density function. So to be a probability density function, f of x needs to be greater than or equal to 0 over the entire of the domain, and the integral of f of x dx between the two endpoints of the domain, the definite integral needs to be 1 as well, because the sum of all probabilities should be 1. So we can check that straight away in two ways. Possibly it's quite such a simple function that we probably don't have to actually integrate it to find the area, but we'll have a look both ways. So part A, f of x equals a half of x for x is between 0 and 2. So it's good for something so simple. You might as well have a look at it. So a half of x, it's just literally a nice simple graph. Straight line passes through the origin, and the origin's one of our x equals 0 is one of our endpoints anyway. So it's going to go through 0, 0, and then when x is 2, f of x is going to be half of 2, which is 1, so it's going to go through 2 and 1 as well. So it just looks like that, and that's it. So firstly, first condition, is f of x, is it greater than or equal to 0 for this entire domain here? For x is between 0 and 2 inclusive, yes it is. Yes, and also we need to check, well, is this area here 1? Because for a probability distribution function for a continuous random variable, the probability is the area. So if this continuous variable can take any value in between 0 and 2, but basically if that's all possibilities that it could be anywhere from 0 to 2, then this area should be 1, because that is a probability of 100% is 1, so the area should be 1. For something like this, you can just work out the area because it's a triangle. So area, or the integral between 2 and 0 of half x dx, we're looking at that, it's going to be, it's a half base times height, 2 times 1, half times 2 times 1, well, half times 2 is 1, 1 times 1 is 1, so equals 1. If you want to check it by integrating as well, or you could say integral between 2, 0 of a half of x dx, well, you could pull the half out, so it equals a half times the integral between 2 and 0 of x dx, which would equal a half times x squared over 2 between 2 and 0 equals a half, and then it's just going to be times 2 squared over 2 minus 0 squared over 2 minus 0. 2 squared over 2 is 4 over 2, which is 2. 2 times a half is still 1. So yes, this can be a probability distribution function. It can be a PDF. Right, part B. Find the mode. So B part 1, find the mode. Well, the mode is the most common. If you think about what this graph means, this axis is never really labelled, but it's kind of like probability density. So if you've done a sort of frequency density histograms, it's a bit like that. Remember, area is the frequency. So the mode is whatever value of this x has the highest y value, and it's clearly when x equals 2. So the mode equals 2. It has the highest probability density, which sort of is a bit like a relative frequency. But remember, the actual probability of x being 2 is still 0. So it's quite a strange way to think about things. B2. find the median. Now the median, remember, the median means it's the middle value. It's the value such that, for continuous variable anyway, it's the value such that half the values are above it and half are below it. So we need to split this, and this is about area. So we need to find the value of x somewhere in here, probably up here actually, this value of x such that these areas are both equal, and they must be a half, because we know that the whole area is 1. So you need to find the value of x, and I think they call it m, that would call it m for median. We need to find an m such that the area above m and the area below m are both equal and are equal to a half. So if we set that up as an integral, so we need the integral between, you can go either way. We could say the integral between 2 and m of this is equal to a half, or we could say the integral of m and 0. I hope you can see that using m and 0 is a lot easier. So the integral between m and 0 of f of x dx, so a half of x dx, so half times the integral of x dx between m and 0, we know that needs to equal a half. Okay, so you could potentially divide through by a half straight away. So we know that this is going to be x squared over 2. If we divide both sides by a half, so that will mean a half, 1 and 1. So x squared over 2 at m and 0 equals 1. Okay, so that means that m squared over 2 minus 0 squared over 2 equals 1, which just means that m squared over 2 equals 1. If we multiply by 2, m must equal 2, m squared equals root 2, which means that m equals root 2. Has to be positive, just look at the graph. It's part C3. We now need the mean, and the mean is the integral, so mean or mu, or even e of x, expected value of x, equals the integral between b and a, and in our case it's between 2 and 0 of, and it's the integral of, in fact I'll write this down, so mu equals the integral between b and a. This b and a are the entire domain of the PDF of x times f of x dx. Right, so it's very similar to your continuous random variables when you find the sum of the x times px equals x sort of thing. Right, so what we are going to do is write x times, and our f of x dx was a half x dx. So that becomes the integral between 2 and 0. In fact, I'm going to pull that half out. So a half times the integral between 2 and 0 of x squared dx equals a half times the x squared is going to integrate to x cubed over 3 between 2 and 0, and you could even pull the 3 out, so equals 1 over 6 times x cubed at 2 and 0. So that's just going to be 1/6 times 2 cubed. 1/6 times 2 cubed minus 0 cubed. I'm just going to ignore that. 2 cubed is 8. This is 8 over 6, which is 4 over 3. So the expected value of x is 4 over 3, which is 1 1/3. Right, the variance, C4, hopefully we'll get room, so C, right, for part C we need to find the variance and sigma. So the variance of x for a continuous random variable is the integral between b and a of x squared f of x dx minus the mean squared. So it's the mean of the squares, the expected value of the x squareds minus the square of the mean. Mean of the squares minus the square of the mean, which is going to be b between b and a, that is 2 and 0. X squared times a half x dx minus 4/3 squared. Right, so what can we do with this? We can pull the half out, equals a half times the integral between 2 and 0 of x squared times x cubed dx minus 4/3 squared equals a half times x4 over 4 at 2 and 0 minus 4/3 squared. Right, so in here you're going to have this value evaluated at 2 minus the same thing evaluated at 0. The 0 is just going to go to 0 because 0 to the power of 4 is 0. 2 to the power of 4 is 16. 16 over 4 is 4. 4 times a half is 2. So it's 2 minus 4/3 squared, which is going to be 4/3 squared, 16 over 9. Well, 2 must be 18 over 9. So the variance of x is going to be 2 over 9. Okay, so that must mean the standard deviation sigma x, we know for any distribution, is going to be the square root of the variance. So it should be sigma x, which is going to be root 2 over 3. So we just square root 2, square root 9.